Hi Calculus 1 students. So this is the last problem of the section on continuity. And let's read the question. If f is continuous on the interval from -2 to 4, and the only solution to f of x equals 4 are -1 and 3, then if f of 0 is equal to 1, we would like to show that f of 2 has to be smaller than 4. Okay? First of all, for this problem, it's not easy, okay? It's labeled as an exercise, so you should definitely have an attempt at it before watching this video, okay? But something else I could suggest is that if you're completely stuck, okay, let's say you're really stuck, you could watch parts of this video, just like small parts that would get you started. This is actually a good way to learn math. You just watch a small part, then you close it and use that little smart part to get the rest of the solution. Okay, you could try that. Okay, now otherwise, if you really have significantly attempted the problem, then continue watching the video. It's fine. Okay. Now, I don't know about you guys, but I find this sentence extremely confusing. So what I'm going to do here, I'm going to sketch the graph of a function that satisfies all of it. And we're going to use it to structure our argument, to structure the proof. Okay? So, okay, now, whenever you sketch a graph, you have to keep in mind the values that you have from -2 to 4. So you don't want to go too far on the negative side. And you want to go like a little bit further away on the positive side to have all of these numbers. And on the y-axis, you need 4. You don't really need stuff above 4. Like the function could go above 4, but not necessarily. So 1, 2, 3, 4. And I will not label this here. I will just put the grid lines because usually when you label this, it's kind of getting in the way. Okay, so what information do we have? Okay. We have that the only solution to f of x equals 4 are -1 and 3. So what does it mean? Okay. So f of x equals 4 is actually the function that is just 4 is actually just the horizontal line that's going through okay. So that would be like another function, like g of x equals 4, let's say. Okay? But f of x, we don't know what it is. We just have an equation that's f of x equals the constant function 4. And what we are told is that this function coincides with 4 only at -1 and 3. So what I mean by this is that f doesn't cross this horizontal axis more than on these two spots. Okay, then we also know that, and by the way here, right? And we also know that f of 0 is equal to 1. This is not saying much, but it's just saying that that's it. The function is going down there when x is equal to 0. So here's an example of a function that satisfies this. Okay, it could start above or below. Just for the sake of the argument, we'll make it start below. Okay, so it has to go like this somehow. Then it matches this. Okay, now you might think that it could go up here, but actually it can't because it would have to go back down and cross the line again. It's not allowed to do that. So it has to go down like this somehow. It could go down in a straight line. We don't exactly know how, okay? Then it goes back up, and this is the big key of the proof. One thing it could possibly do is just this, which would be fine. But something else that it could do is to go above the line and then back down. But this is prevented because the only solutions are -1 and 3, right? At this point, though, it could go up because it doesn't have to go back down anymore to match any of the data points. So this could be an example of a function. So example, right? And here, what do we want to show? F of 2 is smaller than 4. So 2 is here, and this is f of 2. So we see, for example, just based on our drawing, that the statement is reasonable, right? In something that we drew, like just respecting all the condition, we see that this condition is verified. But we want to show it regardless of all the possible drawings. So we want to show f of 2 is smaller than 4. Okay. I was giving you a hint in the problem, and the hint is actually very important. It says to show that f of 2 cannot be equal 4 and that it cannot be greater than 4. Okay, so this was the hint. Show that f of 2 equals 4 and f of 2 is greater than 4 are both impossible. So this means that the proof has 2 steps. Okay, this will be step number 1, and this will be step number 2. Okay. However, before, or actually, should I recall the intermediate value theorem? Okay, I won't recall the intermediate value theorem, but you should have it near. Okay, just to be able to refer to it. Okay, so step number 1. If f of 2 was equal to 4, or actually, I will just say it like this. If f of 2 is equal to 4, then x equals 2 would be a solution to f of x is equal to 4. And this contradicts the hypothesis. Hypothesis that the only solutions are x equals -1 and x equals 3. Okay? So this means, and this was the easy part of the proof, obviously, that that f of 2 is equal to 4 is ruled out. F of 2 equals 4 is ruled out. Okay, I would like to keep my diagram. So what I will do is I will erase the step number 1 and we're gonna continue step number 2. So you might want to take it down, or if you need to refer to it, rewind in the video. Okay, all right, step number 2, I'm gonna go slightly higher. So if f of 2 is greater than 4, we know so I'm gonna use an entire sentence here. We know that f of 0 is smaller than 4. And this is obviously because it's equal to 1, right? And for that reason, we also know that f is continuous on the interval from oh, wait a minute. Okay, good. From 0 to 2. Okay. And the reason why this is true is because it's inside the interval from -2 to 4. Okay, so we are guaranteed here that the function is continuous on the interval from 0 to 2. And as such, the intermediate value theorem, IVT, guarantees a value C in the interval from 0 to 2, for which f of C is equal to 4. Okay, so that is guaranteed by the intermediate value theorem. And this is true, of course, if f of 2 is greater than 4. However, it turns out to be false because, again, it contradicts the red statement that the only two solutions are -1 and 3. Okay, but this contradicts the hypothesis again that the only solutions to f of x is equal to 4 are -1 and 3. Okay, now I will be forced to erase the drawing, but I will use it to explain that last part of the proof, okay? So remember, the red statement, what it meant is that the only time the function is somehow crossing this red line is here and here. Okay, it doesn't have to cross it, it can just touch it. Look here, it touches it, but it doesn't like go up. But the only time it can hit the line in one way or another is at -1 and at 3. So what we have to prove basically is that the function couldn't go above the line, reaching some higher value than 4, and then back down. Okay, because then it would create another solution where it hits that red line for a third time. Okay, so that's how the proof is structured. Now let's erase the drawing and end this whole thing. Okay, so as a result, I will say, let's say step number 3, which is the conclusion. F of 2 is equal to 4 and f of 2 is greater than 4 are both false. And the other alternative is f of 2 has to be smaller than 4. So this is what we wanted to prove. Okay. Just before I end this video, I just want to tell that this type of reasoning is called a proof by contradiction. So what you do is, in order to prove something, you just prove that its opposite cannot be true. So that whatever this is has to be true. So this type of reasoning is called a proof by contradiction. All right, I hope that helped. So this could be expected like in one of your tests after you have like sufficient practice with that kind of argument. If you had the underlying idea, which I showed in the drawing, but you didn't quite write down this, know that you would get partial marks. And I would already be very happy about that. Like if you were able to sketch somehow something and you can explain to me with that sketch why this makes sense, it's already a good part of the reasoning. Like you're working towards solving the problem. So don't forget that math is not about like 100 marks or 0 mark, right? It's not you get it or you don't. Sometimes you have part of the answer and you're just missing like small ingredients, and this is okay. So I hope this exercise was helpful. See you in the next video.